The weight M2G, the masses. So here the weight M2G, or we can show individual. So rather than this, I'll try it here only. This will be M2G. So here the elongation in the spring, so let it be Kx1. This is mg. Here the tension T. So the weight M3G will act. This particular string. So let me assume it got elongated. So spring force Kx2. Here Kx2. Then this is mg. M4G. And the tension this string, let it be say some T naught something, I'll write it. Anyway, because we are going to cut it, no problem. Initially fine, this much. So Kx1, is it equal to M2G? As it is, because all they are in equilibrium. The blocks are, the system is in equilibrium. So because of that, I can equate the net force acting on individual block here. So first Kx1 minus M1G equal to 0. Keep it here. And then this tension acting, so how much of tension should be known? The tension T minus M1G minus Kx1 equal to 0. This is M2. Okay, keep it here, no? This is M1G, M2G. So what is the value of tension? M1 plus M2 into G. Okay, you can treat that everything as an equilibrium or internal. That is all this force, this Kx2, what all acting will become internal. Directly this tension, what all it balance, M3G plus M4 plus T naught. So I'm directly going for it. So let's calculate again the same value, T, or I'll write individually. Okay, then no problem. Then on the block M4, what is the value of T? Now we know M1 plus. So we have spring force value. Kx2 is equal to how much? M1 plus M2 minus M3G. So it may help. No, can we calculate the tension T naught? It's by equating forces now. Kx2 minus T naught minus M4G. Kx2 is equal to how much it is? Now M1 plus M2 minus M3. So T naught should be equal to M1 plus M2G minus. So the difference in the mass of the system on the left and right hand side is what? The difference in weight of the blocks is what? On the left hand side to right hand side is what? The tension T naught. I agree this. So, and anyway, it's given, no? M1 plus M2 greater than M3 plus M4 justified. So what is the state of this green color string? Will be taut. So what is the state of that green color string? It will be taut. T naught is there. Now I'm going to cut it. So if I cut, then what conditions will arise? So the moment I cut at the string at point P, what happened to tension? Will vanish, no? That T naught will vanish. Then we'll see what all will happen here. I'll draw the diagram after cutting it. This is M1. Oh, I'll go for next page. Huh? Let me see. We can adjust here only. Oh, yeah, fine. Okay, now we have diagram. I'm going to cut the string. So don't get scared that one. So come by don't be in hurry burry. So there's such numerical happen really, even for teacher also. If I just do in hurry, no. So definitely I'll miss any one force and I may give wrong answer. So with patience, what happen, you have to analyze each and everything. Come by each one, each on each block, what circumstance will occur. Then what happen, you can conclude it. Here is what that string, which I have cut it. Yeah. No, I think the weight of the blocks will continue to act. There won't be problem with the weight of the blocks. Now, what should happen to the spring force? Kx1. Will it change or remain same or changes? The spring force Kx1 will change only when M1 or M2 will undergo displacement. So what is the state of M1 and M2? They were at rest. So the moment you cut the string open, that inertia of rest, they'll be in the state of rest, no? So due to inertia of rest, what happen? The displacement of M1, M2 will be 0. After some interval of time, they'll start moving. So what is the state of M1 and M2? They'll be at rest. Got this idea? This will be, but sir, this tension can change. Why you're not thinking in that way? Okay, let's do one thing. If I cut this string, so what will happen to first this spring force here? So this will be as it is, no change in that, kx2. So the spring force will not change means, look at the block M3. If the spring force changes, then only the block M3 will undergo displacement.
It will be.
So it will be also at rest. So this will inertia of rest. Better I should not say rest here, inertia of rest here. It will retain state of rest at that instant. So therefore now M1, M2, M3, they'll be at rest, no? Or acceleration, better say 0. Instead of calling, say acceleration 0. So no change in spring force. So spring force will be Kx1, Kx1. So what is A1? A10, A20, A30. So what is about only A4, no? So what do you expect the block M4? In what direction it will move? Up or down? It should move up. Then what is the equation for that? A4 should be equal to Kx2 minus M4G by M4. Do we know Kx2 value? Yes, that's what the thing we brought it, no? M1 plus M3 minus M1 plus M2 minus M3G. So what is the value of A4? Should be equal to M1 plus M2 minus M3 G minus M4G by M4. This will be the acceleration, and what about this acceleration will be directed vertically up. I'm just showing in the diagram. Okay, now many blocks, many springs are there, don't get scared. And the tension, let me show as it is, no change in that. So that word I'm bringing, it will accelerate from rest. So therefore, that's why the acceleration of block 1, 2, 3 will be 0. Any doubt in this? You can clarify. Okay, no, shall we end of the class?
Yes, sir.
Okay,
Okay.
yeah, thank you for
Thank
your
you, sir.
patience.
Thank
Thank
you,
you
sir.
for
Thank you, sir.
thank you for your
Thank you,
patience
sir.
hearing.